So we went off Mars time, and then actually we dispersed the science team. So now we do all what we call remote operations. So for example, today the mission planning for Opportunity started at noon our time here on the East Coast. There's a phone call. People dial in from all over North America and 3 time zones in Europe, sometimes all the way to Moscow. We've got some web cameras. We show what we're doing and we talk about it. And so when I lead that planning, people contribute their suggestions. We wade through those and make sure that what we select is the highest priority stuff that fits within the amount of data and time we have. And that's kind of how we use the rovers. I already showed you this slide, but what I didn't talk about were the instruments. They're basically broken up into 3 areas. There's some magnets that look at just the fallout of the dust. Turns out there's magnetic particles in that dust. There's an arm that's about the same length as my arm. It's got 5 degrees of freedom, and on the end of that arm, which looks very spindly, and is, but remember gravity on Mars is only 40% what it is on the Earth, there are a variety of instruments. There's a thing called the rock abrasion tool, or RAT. The RAT grinds into the surface of rocks so that it peels away that dusty, weathering rind and allows us to see the fresh material inside. There's 2 spectrometers. Spectrometers are things that look at what's reflected or comes off a surface and allows you to say something about its composition. There's something called an alpha particle X-ray spectrometer, which is basically an X-ray machine that looks at that and it emits X-rays and looks at what comes back. And then a Mossbauer spectrometer that uses a radioactive source to bombard a surface and actually get you information about what kind of iron minerals are there. So between these 2 and then a microscopic imager, which is sort of like the equivalent of a geologist's hand lens, we can see the texture and get some information on the chemistry or the makeup, mineralogy, what kind of rock is it that we're looking at. Now all of that together makes up what we call the IDD. We use this based on targets that we pick using our mast up here. Now that ends up being at about the same height as my eyes, and the PanCam camera is about the same resolution as my eyes, about 20/20. It's got 13 filters, so we can get some very crude information about rocks composition or expected composition, something that's lighter or darker, and allows us to pick out things that we can drive over to and then examine. So the mission here was to land on the surface of Mars and explore areas where we thought water had played a role in shaping the surface and say something about how much and how long and how did the water occur on Mars over time. I already mentioned that we do remote operations. This is upstairs right at the east end of the building. My office, this is how we do things. The data is pushed to a computer here every day. We actually use web cameras and a telephone to basically communicate back and forth. Okay, now I don't think this is going to work, but let's see if it does. No. So here is Gusev Crater. To give you some sense of scale on what you're looking at here, this is about 100 miles across, so it's a gigantic crater. It was formed when an asteroid hit the surface of Mars. And the reason why we chose this red spot in the middle as a landing site for the Spirit rover was because if you look, what you see here is a channel that drains into the crater. Now the colors that you see relate to the elevation of the surface. So things that are red are high, orange and yellow is intermediate, and blue is low. So this channel drained downhill into the crater, and if you look, this side of the crater's rim sticks up higher than this side. So it looks like this crater has been filled in by material. And the going in idea was that we would land here and sample the sediments that were carried by this river that drained in and partially filled the crater, lake sediments. Now a big concern about this was we knew from orbital data that right up in here at least there was a lot of volcanic material, lava flows. This crater, this channel are very, very old, on order of 3.5, 4 billion years. And a lot has happened in the universe and solar system on Mars in the intervening 4 billion years. And so this volcanic material was younger, is younger, and buries those lake deposits or that material carried out by this river. What we didn't know is how far down the crater here those lava deposits extended. We were very tightly constrained about where we could land in the crater, because if you remember, for those of you that have been sticking around for a while, the way that we got to Mars was straight into the atmosphere, and we used these airbags, so we had a really big landing ellipse, and some were like 80 or 100 kilometers. So our landing ellipse in this case extended from like here to here. We couldn't move it down because of these hazards here, and if we moved it up, we knew we were getting into the lava. So we tried to pick a place and hope to land where we wouldn't land on those lavas. No more suspense, we landed on the lavas. So we drove away from where we landed. This is where we landed. It's a very smooth surface. The rocks that you see here scattered around the surface are actually basalt, just like you find in Hawaii, that are carried by volcanic flows. These have been broken up and tossed around by small impact craters. And after we realized that, we drove to this area called the Columbia Hills that was southeast of where we landed. The Columbia Hills poke up through these lava flows. They're older, they've been surrounded. So think about somebody builds a dam and you got a hill in the middle of it. You close the dam and the lake fills up, and now that water comes up and surrounds that high point. It's the same thing that happened here with the Columbia Hills. So we decided that because this was older and poked up through this material, that we would go there and see if we could find evidence of this past water on Mars. Now I should point out at this stage that the rovers were designed to last 3 months and go 600 meters. 600 meters is about, I think it was about a fifth of the way to the Columbia Hills. But we'd also at this point been on the surface for about 45 days, half our nominal mission, and we're starting to realize that because we landed without incident, we didn't break anything on landing, that the rover was actually quite robust. And so we decided that even though this was further away than the rovers were ever intended to go, that we might make it. And that in fact, because this offered such a tantalizing science target, it would be worth going there to see. So we did head off to the Columbia Hills. This shows where we landed. We drove up to a small crater here, seeing if we could see through the lava basalts. We could not. And then we drove off towards these hills down here. And every little white dot that you see along the way shows you how far we drove one day. So some days we would only drive 10 meters. Some days were really good days and we'd drive 100 to 120 meters. Remember, this thing was only supposed to go 600 meters the entire mission. Full speed, doing something that we call blind driving, which means that I've got a picture of what's in front of me and I know there's no rocks between me and the Uranus globe over there. And I basically just put the pedal to the metal and go. I don't worry about running into something. Full speed doing that, 2 meters per minute. So when we drive 120 meters, that's 60 minutes of driving. These are solar powered, they charge up every day. It uses a lot of juice to turn those wheels and move this golf cart along. You know, so those of you who play golf, you plug in your golf cart at the end of the day. Same kind of thing for this. So we were limited by power, time, but also by imagery. We can't see far enough from where we're standing to know that, okay, I know I can go to that globe of Uranus, but two galleries down where they're doing Pioneers of Flight, I don't know what's down there, I can't see it. So I don't want to drive that far, because I might run into something. So that's why we drove, 10 meters to a little over 100 meters per day. We finally made it to the Columbia Hills, and we were rewarded pretty much instantaneously with what we had gone to look for. In contrast to the flat plains that were largely just a volcanic lava flow surface, these rocks, which were much older, looked very different, and very quickly, before I get to it, I'll say a little sidebar. This is one of my favorite pictures from either of the rovers. This is an outcrop that we named Longhorn. We've driven up off the plain, so you can see we're getting up off the surface. And what you see in a very faint orange here in the distance is the far rim of Gusev Crater, something like 40 miles away. So you really get this vista across the surface of Mars. So when we looked at these rocks up close, I thought I had it here and I don't. What we saw, let me see if I can find an example, right over in here.